Hello everyone, today we are going to be going over the blind 75 in C++, and today we're focusing on the problem valid anagram. Now, before we get started, whenever we are breaking down a following problem, we always ask ourselves these following 4 questions. What are inputs going to be? What data structure / algorithm / technique to use? What to do with the data? And finally, what are outputs going to be? So, to be able to break down our following problem, and also feel free to pause the video to be able to write these down while we're coding along. To break down the problem now, given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So in our first example, we have the input of s is equal to anagram and t is equal to n-agram. Whenever we rearrange the words all together, will it be the same? And so we already found that these are the same word, and so it's considered true. Our second example has the input of rat and car. Though we have the same number of characters, these are totally different words in particular because they're not the same characters. And so we also have our constraints. S and T consists of lowercase English letters. That's good. And so to be able to give a breakdown from our problem, we already know that we have two strings, S and T. And the following data structure / algorithm / technique we're going to use one map to keep track of the frequency of characters for both S and T. And what do we do with the data? It's going to be the following steps. Overall, we will keep track of each character in our maps to determine if they both have the same number of characters and the same type. So the steps that we need to do is that first we need to initialize our map to keep track of the frequency of similar characters between variables s and t. Then the second step, we are going to loop through the s string and increment the frequency of characters for s. Then the next part, we will loop through each character in string t. In doing so, we will decrement each character and the frequency map. And overall, finally, if there is a non-zero number, we will return false if the frequency map didn't turn to 0. So now, to be able to give a full rundown of our following solution, it will be this. So let me just move this up here just for reference. So now we're just going to be able to create our first map, an ordered map for character, integer, and then frequency. We'll just call it frequency of s over here just to specify, or we can just call it frequency A to indicate for the whole set of strings altogether. We can call it whatever. And then what we will do is that we are going to be, so this is going to be step 1, step 2, step 3, step 4. For step 2, we're going to be doing a loop through each of the characters within the S. So character right here, S, and then we're going to increase A per character. Let's say right over here. Then we're also going to do the same thing for our T. Loop through string T. This is going to be looping through string S. Step 1, we set up our map to keep track. And so we can literally just copy, paste this right over here, except for the key difference is going to be we change the S to a T, indicated by the parameters up here. We notice that we have a Boolean of S, and we also have T as well, so we can call upon them for our solution. And then, but mind you, we're also going to be decrementing as well, and decrementing the count to see if we actually have the same amount of characters. Now, what we will be doing is that if any count in our frequency is non-zero, we return false. So for auto entry of frequency S, if the entry dot second doesn't equal 0, we're going to be returning false. We go down, and then finally we'll have our step 5, which is return true if S and T are anagrams, and false otherwise. So overall, we will return true. I'll specify this over here. True if an anagram. There we go. If true, return our anagram. No, well, we don't return an anagram. We return true if we found an anagram. There we go. So let's just test this bad boy out. Make sure it passes all the test cases. And we have a bit of a error. Auto entry. Let's see. Apologies on that. I misrepresented. I just added the wrong syntax. There we go. It passes all the test cases, and let's submit. Okay, and so to be able to give a breakdown on our full solution as well, let me just clean this up for you folks so you actually see what we were talking about. I'm also going to post this in the description as well for our solution. So the time complexity for our given solution is O of n, where n is the length of the input strings, and of S and T, where we iterate through each character once to build a frequency map. The space complexity, on the other hand, is O of 1, because the frequency map will have a fixed number of entries based on the character set. In this case, the character set is assumed to be lowercase English letters, which has a constant number of characters. And overall, we have a pretty optimal solution, as also indicated over here. And yeah, so this was Valid Anagram. Thank you again for taking time to be able to watch this. If you found this helpful, be sure and feel free to like and subscribe. And if you have any other questions or comments, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.